Welcome back. I did a little investigation, a little bit of research into assembly this morning. I watched Fireship's assembly in 100 seconds, so we got the stuff covered now. Went and had breakfast with a friend. Now I have a cup of tea, so we're ready for a coding session. Just as a quick recap, we created an interpreter in the Odin language, which so far I'm quite enjoying. I'm sure I'm getting a few things wrong, or at least I'm not doing things idiomatically yet. I am quite sure. But so far I've really been enjoying it. It has some great features. My favorite feature so far is the switch case, the switch statement. And our interpreter that we've written is for a language which I have called barely a lang, although it is just a blatant copy of some wrong window. Let me open a new window and close that one. Basvidal 97. So I just copied his language. He also has a Python interpreter, which I barely referenced. I just kind of did it from scratch. And this is the language. Very simple. It's basic, it's very assembly-like, it's just like, here's the operation, here's the argument, here's a label to jump to. Simple. So, a couple of goals today. Firstly, personally, I just want to try and be a little bit more engaging with the way I talk. I feel like that's something I can work on a bit. It is a challenge with these videos, to keep things moving, engaging, and when I get stuck on something or I'm thinking about something, not to just stare at the screen blankly. That's a bit of a habit of mine that I want to try and get a bit better at. Oh, another thing I wanted to do was time it, so I'm going to start my timer. Try not to go past an hour. Try to keep these sessions under an hour. And the third thing was that I wanted to set some goals at the start, so we have kind of like a bit of a structure, a bit of an idea of what we're trying to achieve during the video. So the first thing I want to do is just a little niggly thing where I feel like I could have done it better in the switch statement on our commands when we're interpreting. I don't feel like this was very nice. It's a bit complicated. And then I have this here, before I continue to make sure that it always gets set back to none, but it feels like this could easily, like if I'd accidentally put it down here, then if this happened, it wouldn't get reset. And, it doesn't feel so robust. It feels a little bit fragile. So I just want to do a little bit of cleanup of this. Then we want to create not a new project, but we want to divide our source out. Probably make a common folder and move our tokenization code into a common folder. Because this tokenization, it's the same language. So we're extracting the same tokens, so just to back up a second, after fixing that niggly thing, the next thing is we want to start on our compiler. Because we wanted to create an interpreter and a compiler for this language. The interpreter is done. So I want to extract the tokenization code into, I guess, a separate folder. I haven't really figured out in Odin how packages work very well, but I think it's something to do with folders. And also at the top of the file, there's this package thing. So we'll try and work that out so that we can extract our tokenization code into basically, we just want it in a common file that we can reference from the other two, from our two programs, which is the interpreter and the compiler. Then we want to just get some really basic stuff compiled to assembly and create an executable. In the beginning, we're just going to make it so that it doesn't crash, because assembly by default, if you don't explicitly tell it you're exiting, then it will crash and give you a segmentation fault. I don't know if that's on all platforms, but I guess x86 does do that. I don't know, I'm very new to assembly. So we want to at least make it so that it exits nicely. We're going to set up NASM as our assembler, get that little basic assembly going. And I think that's probably pretty good for this hour. Nice to have would be getting, maybe if we go back to our barely 01, I mean, these are quite a few instructions to implement. So maybe we'd start with something like print. We'd probably just try to do some things that we can just do on their own. So halt is going to be the first one, that's exit. Then we want to print is the next thing. And maybe read is the next thing, because we could do a read and then just print what we read, maybe. Anyway, I don't want to define that too much, but now we have an idea of what we're going to try to achieve this hour. So let's start with this thing in the interpreter that I did not like so much. The first thing I wanted to do was move this current jump type down here so that there's no need to reset it. That alone, I think, is a nice improvement, because that means that we can take this away. And having it outside of there just means that every time we come into the loop, we're automatically setting it to none. Yeah, I feel it's just a bit more robust in here, because there's a few different flows here. We're continuing here, we're breaking here. Well, break just breaks out of this for loop. But anyway, I feel like it's more robust to have it outside. And then the next thing is actually, instead of having this as a case, I'm thinking maybe just to move this whole logic out of the switch statement and just say, if current jump type does not equal jump type.none, then we do our jump logic. And then we get rid of these fall throughs. We don't even, since we're not falling through, we don't need to check if it's none. And I feel like that's a nice, can we just do this? You can kind of omit. It seems like in, see, we did it already here in our switch statement. And that's why I thought maybe you can just, for enums, it seems like, it knows current jump type is of type jump type. So why repeat jump type here? I guess. I'm just going to check to see if there's anywhere where I have jump type dot. No, I don't. Okay. And now it tells me, actually, you do need that. Okay. So, but yeah, that simplifies the switch case, the switch statement a lot. So it's just like, if we're saying to jump, then do this. And then, you exit by default, after we've executed the case, we exit the switch. And then, if at any point the current jump type got set, perform the jump. So that wasn't very difficult to refactor, was it? And we can go like that and get a C? Yes. So it seems like it worked. So I'm pretty happy with that. Simple change. I will just say Lang 04 tidied jump logic. commit that. I feel like that should be a separate commit. Okay, so next thing we wanted to do was extract our common code. So I think I'm going to need to, I'll just say common. And here's our tokenized code. So tokenize, copy that, and we'll make a file tokens.odin. Wow, that did not work nicely. Maybe we need to do like tokenize, which is a procedure. I've seen this before. The copy paste. Oh, why is that? What's the problem with that? It's just an empty procedure. Probably I need to do package common or something. There we go. So now if I paste, okay, now we get it nicely. We're going to need to, is it import? Core format. Yes, it was import core format. Maybe we'll just do, let's do things the Odin way, hey? And we'll return an array of tokens, dynamic array of tokens. We need to name them. So tokens, and then an OK flag. Oh, just a string. Our tokens are just strings. So what that does actually is that declares that as a variable, so I don't need to declare that variable. See, it's probably saying direct shadowing. Yeah, so we can just get rid of that. Have I been putting all my opening braces on the? I have. Interesting. That must be because that's what I'm doing at work, and also what I saw in the Odin examples. Typically, I like this. Maybe there's going to be a lot of opinions about that, but for now, since I've done this up to now, I'm just going to keep with that for now. So yeah, this syntax here, with the arrow to a couple of variables in brackets, means we're returning these two variables. So, and we take in source, which is a string. So we're converting, it's a transformation really from source to tokens. And we want core strings. What else is complaining about? We need OS. So actually we don't want OS. This is kind of what I was getting at. So here I'm going to say OK equals false, return. Equals false, return. Okay, it's false, return. Missing return statement at the end of the procedure. So I guess you still need to put return, an empty return. You don't need to explicitly say what you're returning because it's already known that these variables are what you're returning. So this is kind of interesting, isn't it? Because I'm going to be filling this token array, but then at some point things go wrong and I just say, well, okay, it's false, return. So I'm going to return like a partial array of tokens, I guess, and an OK flag that says, you know, this is actually not a successful tokenization. Okay. Since a string owns its memory, I think what I watched another video this morning where someone was talking about different array types and slices, which I didn't really know about. But I think, no, but it's a single string. I don't think we want to slice here, but we can go, is it string pointer, pointer string, pointer to string? I think we want to pass in a string pointer because we don't want to copy this, the whole source, right? I mean, eventually we probably want something more like a stream, potentially. Well, actually, probably our tokens would want to just have slices of this. That would make sense. We just have the source in memory, and then each token has a slice of it. A slice being basically a view into a part of an array, or in this case, a string, because a string is basically just an array of characters. So what is the complaint now? Because it's a pointer, so we need to how do we do this? Like this. So we're saying this is a pointer to a string, and maybe this is the way to say what the string is pointing to. It's a bit new to me, this pointer syntax. I'm used to the star, the C style with the asterisk and the ampersand. They still have the ampersand use in here, but I'm not really sure how it works. Anyway, now that we've got that extracted, let's see if we can just cut that out of here. And say that our tokens are the result of common.tokenize. And we need to give so this is where we use the ampersand, the address of source. But we need to go, okay, tokenize. So this is how we retrieve our two output, and then just like we did here, very similar pattern. I think there's a shorthand for this. I think there's a shorthand for this. Odin error handling on return. Explicit procedure overloaded, so it's going into lots of different things here. Error handling discussion. There's Ginger Bell, he's the guy who created it. I don't want to go into this too much. Let's just leave this as is. Maybe offline I'll do a bit more investigation. I feel like there's a way that I could just, can I just do like if, did that work? File scope statement expected, comma got 4. I think that does not work. Yeah, that's what's causing that error. Okay, let's not worry about this. Let's just say if, I'm sure there is a way that we can do a shorthand for this so we don't have to have the statement that gets the tokens and then a separate if. I feel like we can combine it, but let's not worry. So failed to tokenize. I feel like we don't even actually need to print out because the tokenization will already print out what the error is. If I run that, exit with code 1, probably we need to go OK equals true. So probably it defaults to false, doesn't it? Everything is 0 initialized in Odin. 0 is false. Yeah. Yeah, so I just had to say OK equals true at the end. Okay, that's nice. And that worked. So now we have it extracted. We have our common, we have our interpreter with a main. So now, we create our compiler. Yeah, whatever, that's fine. Okay. .. common. Okay. Actually, I'm curious. It seems like it does still use all these things. Yeah, I think these will gray out if they're not used. So in the compiler, which we call barely AC, the other one, I called it barely AI, which is probably a bit confusing because of this, but it's barely A as in barely a lang. So barely, I guess it would be an interpreter, but anyway, barely a interpreter. Because, you get like Odin lang, which I don't know. I think Odin, the program is just called, the compiler is just called Odin. It's not called Odin C. But it's kind of a convention that you call it like something C for compiler. So barely a C now. Anyway, so we've got our tokenizing stuff. It's tokenized. Now, we don't need to have our stack here. We're going to compile. So we're going to jump through, and for a lot of these operations, we're just going to leave it empty. They're not done yet. The jumps we will leave in, the halt, no, and then if it's a label, just continue. I feel like that's not even right, but we'll do that for now. Because now that we're doing assembly, we're actually going to have to put the label in the assembly that's output. So when we come across a label, that's going to have to be, a real thing that we deal with. But not yet. Not yet. And this code that actually performs the jump will need to change. Yeah. Actually, that's more of an interpreter thing. I don't think we need that logic at all. We don't need that. That's something that the CPU will have to deal with. When we interpret it, we were doing execution. Now the CPU is doing execution. We don't need to worry. So the first thing I think we want to implement is halt, right? And we want to write a file. I think there's like a string builder. What about Odin stream to file? Odin file writing, reading a file. So I know it was like os.read before. Now we want os.write with a handle, write string. So I guess first we want to do, well, I guess it's like an OS open, right? OS open, and it's like we'll just call it out.asm assembly file. Oh, been doing too much TypeScript. Requires, okay, so yeah, output file, open asm. Do we need to give it a mode? Yeah, see the default mode is read only. So we want like os.mode t? No? Write only. Let's call it create. Okay, let's try that. Open, okay. And then we can say, if not open, okay, can't write out.asm. Oh, did I get that wrong? It's not a Boolean. Error. Yeah, so if open error does not equal nil, I guess it can be nil. An error. So this is shared nil. That's the reason I got the idea that maybe it could be nil. I mean, these are obviously types of errors, but if there's no error, that's what I guessed would be nil. So it does not equal nil. That means there was an error. I can't be bothered figuring out what error it was. I don't know if this is the right mode. We're just winging it. But now we have our output file. So when we get to a halt, we should be able to write some assembly. Before we start, actually, we need to os.write string to output file handle string. What we need to do at the start of the program, if I remember correctly, is declare a global start, and then we need to say put the start label. So I think start is underscore start is the label that would be executed. It's the entry point. It's the entry point to the program. So I think this is a comment. I want to put lots of comments in the assembly because it can just become, like a wall of text. Like to a degree, this here is like a wall of text. It's hard to parse into something that makes sense to you. So I'm going to put a lot of comments in. So this one is entry point. Start is the entry point. So before we do anything, we have to say, look, we have an entry point and it's here. Then we go through all of our commands, and halt is the first one I want to implement. So I think I'm going to just for each of these commands, I think I'm just going to start with like a comment that says what it is, what instruction in our language we're handling. So I think it's like move rex 60. I've seen a few videos on assembly, but let's go. So another thing to say is I'm on Linux. I'm on Ubuntu, Debian, Linux. So I'm going to be writing using Linux syscalls. So in assembly, I thought assembly was just assembly. I guess it is obvious that for different, for ARM and x86, those are the two big instruction sets. They have different instructions, so obviously you're going to need different assembly to handle them. Can't forget that I have some tasty tea. Then beyond that, it depends on your OS, because there are some ways to interact with the OS, and they are called syscalls. At least I think that's the terminology on Linux. I don't know if Windows has a different terminology. But so depending on your platform, there's going to be different syscalls and different ways to call those syscalls. So let's go x86 Linux syscalls. Linux system call table. Actually, Chromium, I think I remember someone going to this one. Yeah, I've seen this table before in a video. So if the syscall name, this is the number. So the number is what you need to put into the RAX register. And then there are some other arguments that you can pass to these syscalls. And those arguments, you need to put those values in these registers. So the first one, our halt, in assembly terms, or at least in Linux syscalls, that is an exit, which I believe is 60. It's an exit. So in RAX, we put 60, and then we put the error code in RDI. And I'm probably getting the syntax for these commands wrong, but I believe move rex 60 syscall exit. I believe that is moving the value 60 into the RAX register. So we do that first. Then I think it was RDI is the exit code. So I'll just say exit code. And then we need to call the syscall, which I think the command is just syscall, like that. So we set up, we say, this is the syscall we want to execute. Here's our first argument and only argument for exit, and then we call the syscall. So that should exit with an exit code of 0. Let's see, this is my first attempt at assembly. We don't even know if it's going to write the file correctly. So let's copy this and make it barely AC test 01. And then instead of interpreter, we go to compiler. So it looks in there, and the output, barely AC. And let's run it, see what happens. unknown token L1. Oh, that's interesting because just before when I did the Barely AI, is that also gonna? No, this one's like I can go 5, 6, and it says they're not equal. So that's working. Barely AC, which has the same. Oh, we don't need string convert anymore. Which has the same tokenization. Ah, okay, can't write out.asm. That's because our flags here are not right. I can never remember these flags. Odin file overwrite existing. See, I think Odin is so young as a language that it's hard to search for these sort of things. So if I just say file flags, overwrite flags in a file. Read write. You can write the contents to a file like so, write. So maybe I just want write only. Is that going to replace the existing file? Can't write out.asm. Clear read-only status. Still can't write because we need to create. Damn it, I'm not very good at this. These flags. I need to combine some flags. File flag overwrite from beginning. Overwrite a file in Python. I know I'm happen to be getting these Python ones, but I imagine the flags. Essentially everything's going down to the operating system. So is he actually responding in Lua? To overwrite files, SSS and RRR every time you run the code, you need to open them with the mode W instead of A. The W mode overwrites the existing file, whereas the A mode appends to the existing file. So you need to change these lines. So in Odin, I'm trying to think which of these, OS Windows? That's already weird. I'm not on Windows, so I don't know why it's going to this. But write only feels like the closest to a W that I can see. Definitely not append. Truncate. So can I do like this and go and pass in multiple flags? And I'll just try a bunch. So there's another one I was interested in was truncate. Can't write. Why is it giving me this Win32 stuff? This stuff, that's a bit scary. I feel like it's showing me the wrong thing. I don't know if I can go in here to OS Windows. Is there an OS Linux? I mean, I feel like the flags should be agnostic, but can I find an open proc in here? Not. No. Yes. See string flags. Yeah. Still got the same. I feel like it's the same flags. Yeah, which is what I would expect. I mean, you don't want to have to change it for different operating systems. I think I'm going to, because this is taking too long and probably not very interesting, really. I think I'm just going to delete the file every time for now. Kind of sucks, but better than going through all this crap. Okay, so instead of deleting that file, let's have a look. It's an empty file. Well, that's not very handy. Let's start write string. Maybe I need to like flush or something, or close. Probably closing might be a good idea. And what you can do in Odin is once I know I've got it open, I can defer closure. So I can have it all together like this. So I need ampersand. Close handle. Oh, that's not the handle. Output file. If I go like that, get an out file, which is still empty. Odin file writing. I don't immediately see the answer, so I give up. Right, no, that's not interesting. Maybe I can just go to the overview. So does it have files or I probably should have fast suffixes as conditional. Okay, I don't see it there. I think it's probably in the packages, in the core library. There should be OS here somewhere. OS. Okay, I wasn't expecting it to take me like that. So OS dot open doesn't give us fuck all documentation. So that's not very helpful. Write string. Which does return an error, so we could check for an error if there is one. Stream.odin. Write entire file, that's also a possibility. If we go back and we go to strings. There's a builder. So another approach we could take is strings.builder init, builder make, builder destroy, builder from slice. Why can't I scroll across here? That would be nice, wouldn't it? See a bit more. Builder reset. Pointed to a builder length capacity. So can I just say builder? Missing argument. So it needs a buffer of bytes. That's just a dynamic byte buffer, so not a big deal, I don't think. They use append, no. Strings dot. I feel like I'm not doing very well here. I don't really want to, like spend a lot of time understanding, trying to find the best way to do it. At this point, I just want it to work. Let's call it read write. Well, it is saying unknown token, isn't it? L1. Maybe that's why it's empty. But it gets to hold first. No, it gets to this L1 is where it's having trouble. That'll be why it's empty. No, well, it should have this, shouldn't it? But when it gets to unknown token, it just exits. Okay. So it never gets to actually close, although it is deferred, but it exits. I think that means the defer does not get called. So let's just say if we see an unknown token, we don't really care. Yeah, a bunch of unknown tokens, but who cares? And our output file is still empty. So maybe we can go blah, blah, okay. Is that I think it's an error, isn't it? Yeah. Can't write to. So it's able to write. Seems like that's not throwing an error. So why are we getting an empty file? That's the question. Do we need to specify that we don't want a binary file? I feel like normally when you're writing to a file, well, we're writing string, right, which is just calling write. But I feel like normally there is a mode Odin write text file. Please help me. Reading and writing markdown files with Odin. It's a library, so it's not actually. Parser write.odin. Write to file calls write to string. And then it does OS write entire file. And it creates a builder like this. All right. Let's copy what they have done. Hopefully that's going to help us. Hopefully that's going to help us. Because we're going around in circles here. And it's not so nice. So we need to give it a capacity. It does have an allocator, so I'm not sure if the capacity, and you've got an optional allocator error if none, if one occurred, nil otherwise. Desired length, the desired capacity of the string body. I can just make with length. I think that's all I want. I don't want to specify the capacity. Is there even just a builder make? None. Let's see what happens with builder make none. I mean, I hope it will dynamically allocate space to the string. And then you can do strings.write string or write rune. Okay. So here, basically want to transfer all this stuff. So I'll copy that. When we get down here, we do. So actually, we just want to go place that with, whoops, that. So everything is written to there. And then at the end, we do, he's gone strings.toString, and then he's cloned that string. I don't know why he does that clone, but let's do write entire file. Oops. So at the end here, always write entire file, out.asm, transmute. Strings.toString. Do we really need to do that? Write entire file. I don't know if there's write entire file. There's read entire. Write entire file or error. Write pointer, read pointer. I don't know if there's a. I was looking to see if we could do it directly from a string, but I don't see it. So we'll do this weird transmute business, whatever that is. I guess it's kind of like just like a cast. like it's saying, hey, reinterpret this, like a reinterpret cast. Maybe. So we don't need this file stuff here, and then if I run it, get an out.asm, and we have our code all on one line because we didn't do any new lines. But thank God it's working. We actually got something. So new line, new line, new line, new line. So everything has a new line. Run out.asm. Look at that. That's assembly. That's what that is. I think what I've seen before is people indent. So like labels, they don't indent, but actual commands, they do. Let's see if I can. Okay, and it overrides the file as well. Perfect. So we're halting twice because we have two halt commands, which is totally fine. Whatever, this first syscall will get called, which will exit the program, and then this will never get called. No big deal. Now what we need to do is compile. So now we have the assembly code. We need to compile it to, I guess, to machine code, which is what the assembler does. I think I'm probably getting my terminology wrong there. Then we need to link it, which combines it with any other code that it's referring to, which might include the syscall, I'm not sure. Probably not. And then we can run it. And we're almost an hour into this. So hopefully we just get this working, and that's enough for this session. So NASM is what I discovered would be the nice thing to use. So let's install NASM. Oops. Fatal, no input file specified. So we're in Belialang bin. We actually want to go up one, and then we want to go NASM out.asm, and then I think it's -valve64, which is saying that the format is ELF64, which is the Linux format. I don't know much about it. I just know ELF is 64-bit, obviously, these days, and ELF is Linux, something like that. And we want an object file, out.o. What does that do? It's not name, it's NASM. Oh, maybe it should be like -o. Whoa, out.o. Then do we have LD? Yes. So we go LD out.o, I guess -o again, out. And we have out. Okay. Then we go /out, which executes. And we didn't get a segmentation fault, which is what I was hoping for. Segmentation fault would be if we did not exit successfully. And what we can do is, if I can remember correctly, is it $? Yes, that gives us the exit code. So let's just do a little test before we finish up. If we make the exit code 10, compile that again, then we run our other steps. Where are we? So we go to an object file. From the object file, we link. We run our executable. We look at the output code, and it is 10. Success. Our first assembly. Stoked. So, I mean, it's really simple what we've done so far. I mean, we stumbled a lot because we don't know Odin. Unfortunately, that's going to happen each time we try to do something new like this, like in this case, writing to a file. I still feel like this is not the most efficient way to do it. I feel like we could have streamed directly to the file instead of using the string builder. String builder, because we're not pre-allocating anything, is probably doing a whole bunch of allocations. It's not very efficient, but whatever. We're done. We have our assembly with an entry point. It looks nice. It works. We're reading the file, tokenizing, same as we did for the other interpreter. Create a string builder, then we create our entry point label, and then the only command we're processing so far is halt, where we do a syscall to exit. And I'll put that back to 0 because it should be 0. Voila. Enough for today.